business. Let us start. All right. So, yeah, I wanted us to start indices today, but I just remembered to say on sets, I forgot one very important topic, which is the binary operations. So we're going to start with first defining what binary operations are, and then we look at the type of binary operations, and then the algebra, laws of operations, and then we'll also do one or two questions concerning or pertaining these same binary operations. All right, so we can start. What are binary operations? So binary operations is simply just a rule for combining two values to create a new value. What does this mean? So a binary operation is just an operation. For instance, addition is an operation. Subtraction, multiplication, and division, those are operations. So we just use these operations to combine two values in order to come up with one value. Let's take, for instance, if you have two, okay, let's take, for instance, if you have 2 and then you also have 3, and then you want to combine these two numbers, what do? If you want to combine, if you want to add them, it means that you're going to have this operation, and then you have your answer to be 5. Then if you have 3, then you also have 1, and then you want to reduce this 3 by this 1 here. It means that you're going to subtract. So in this case, the operation that we have is subtraction. Then you get your answer 2 there. So this is basically the definition of binary operations. Okay, so the examples of binary operations are these. They are also known as types of operations. We have addition, we have subtraction, we have multiplication and division. Yeah. So these are the main important binary operations that we have, the types. Okay. Let us now look at the laws of the algebra laws of operations. So these laws are, we have the commutative law, we have associative law, then we also have the distributive law. There are also other laws, but for your level, these are the most important ones that you need to know. So let us look at the commutative law. So commutative law is just simply the change of the order of numbers or letters. So let's take, for instance, you've been given 2 plus 3, and then you get your answer there. Then you also have 2 times 3. You also get your answer there. You also have 3 divided by 2. You get your answer there. You also have 2 divided by sorry, let me not use division there. Okay, just want to have a few examples here that will help you understand what I'm trying to talk about. Then here when you say 2 plus 3, you get your answer to be 5. So when you change instead of starting with 2, you start with 3. This side you say 3 plus 2. Are you still going to get 5? If you are still going to get 5, then addition is commutative. Then addition is commutative. Let us now try to look at this one here. 2 times 3, you get 6. Is it the same as 3 times 2? If you're still getting 6, then this multiplication is also commutative. Now let us try to look at this. 3 divided by 2, let me just leave it in a fraction form. I'm going to have 3 over 2. What of now? 2 divided by 3. 2 divided by 3, I'm going to get 2 over 3. Are these two answers the same, this one and this one? If they are not the same, then division is not commutative. Same applies when you have 3 minus 2 and 2 minus 3. We're using the same numbers. We've just swapped them. Commutative is basically just about swapping the numbers without changing the operation. So when you have 3 minus 2, you get 1. 2 minus 3, you get negative 1. Are these two answers the same? If they are not, then subtraction is also not commutative. So addition and division and subtraction, they are not commutative, but addition and multiplication are commutative. So this is the definition of commutative law. Yeah, there's no other definition of it apart from this. So this is what I'm trying to talk about in this explanation. There, 5 plus 4 is 9, and 4 plus 5 is still 9. The 5 and the 4 can be switched in addition. Same applies to multiplication. There, 9 times 2 is 18, and 2 times 9 you still get 18. The 9 and 2 can be switched in multiplication, but when you try to apply it on division and subtraction, you discover that it's going to fail. So, meaning division and subtraction do not obey the commutative law. Okay? So, let us try to see what we have. Okay. Associative law. So, associative law is just basically by shifting the parentheses. You shift them. What do I mean by shifting? Let's take, for instance, you have 2 plus 3 plus 8. So I'll say this one being equal to, so I'll repeat the same numbers, 2 plus 3 plus 8. Yeah, like that. So I'm going to have this. Let me just put the parentheses outside there. I'm going to have this in brackets. So what I mean by shifting these parentheses, I'll shift them, I'll put them this side. So if you follow BODMAS, you discover that you always have to start with what is in the brackets. So when you start by adding 2 plus 3 there, you get 5. And then when you add it to 8 there, 5 plus 8, you discover that your answer will be 13. Now let us try to see if we're going to get the same answer even this other side. So we start with what is in the brackets there. 3 plus 8, I'm going to have, first let me write my 2 there. So 3 plus 8, I'm going to have 11. So when I add 11 plus 2, I'm still getting 13 there. So when you look at these two values, they are just the same, which implies that addition obeys the associative law. Yeah. So you can also try to test this associative law on subtraction, division, and multiplication. So when you test them, you are going to know whether division and subtraction and multiplication obey the associative law. But I've given some examples here about division, about all the 4 operations actually. So it's just a matter of you going through them on your spare time. So you can see that one is just an example. Yeah. Okay. This is just an example for addition. So you have to note to say what was moving here was not the operation, were not the numbers, but the parentheses, the brackets. Yeah. So here on associative law, it was just a matter of moving the brackets and not anything else. So let us look at an example of associative law of multiplication. Yeah, you can see there when you multiply 5 times when you start with what is in the brackets there, you multiply 5 times 6 there, you get 30. 30 times 5, you get 150. Same applies this side. When you start with what is in the brackets there and multiply with what is outside, you get 150. So multiplication is also associative, or it obeys the associative law. Now, doesn't it work for subtraction? It's a question. Can subtraction or is subtraction or does subtraction obey the associative law? Let us try to check. So you can see when you work out the operation on this side, you discover to say you get your answer to be 0. When you work out the operations this side by just moving the parentheses, you discover to say you get your answer to be -4. So since the answers are not the same, it simply means that subtraction is not associative. So let us now try to look at other things again. Now, how about division? Does division obey the associative law? Let us try to check. So you can start with what is in the brackets there. 10 divided by 2, you get 5. 15 divided by 5, you get 3 this side. This side, when you start with what is in the brackets, 15 divided by 10, you get 3 over 2. 3 over 2, which is here. Then when you divide it by 2, you get 3 over 4. The answers are not the same, meaning division does not also obey the associative law. So these are the basic things that you need to know for you to first know how to solve the binary operations that involve a star. I know that one gives hell to a lot of people. A lot of people, most of them, 3/4 of the NS students fail such questions. I don't know, but they are the simplest questions. And I guarantee you that after this lesson, you'll never fail such a question because it's very simple. Yeah. So let us proceed. So all you need to understand is this same commutative, associative, and distributive. Once you just know these, you'll never go wrong on binary operations. So division and subtraction do not work under associative. So let us try to look at distributive. So distributive is very simple. When you talk about distributive law, we're simply talking about, let's say for instance, if you have 2 there, and then you have maybe, you have 2, and then you open the brackets, then inside the brackets, maybe you have 3 plus 6, like that. So your distributive law implies that you have to distribute these two to all the numbers there inside. So meaning 2 times 3 there, you get 6. 2 times 6 there, you get 12. Then when you add the 2, you get 18 as your answer. So this is distributive law. It's just as simple as this. Yeah. So yeah, so it's saying multiplying everything inside parentheses by what is outside it. Yeah, that is basically the definition of distributive law. So examples of distributive law, we have this one there. You can see there A is outside the parentheses. Then we have B, C, and D inside. When you multiply through by A, that is what you're going to get. Yeah, let us try to look at a quick example here, a simple example, before we start dealing with the computations of binary operations, which involves a star. So you can see that you have 5 outside, and then you have 2, 6, and 7 inside. I mean -7 inside there. So you distribute that 5, you have that. then you discover that when you add 10 plus 30 plus 35, I mean minus 35, you get your answer to be 5. So when you have combined operations like subtraction and addition, if there is also multiplication there, you first have to start with multiplication, because BODMAS, according to BODMAS, you need, according to this law here, which is BODMAS, you need to follow this law carefully when you're solving any math question. It's very important. So you can see brackets always comes first, and then this O, there's a certain word on indices. I've just forgotten it. I'm sure I'm going to remember it the time I'll be teaching indices. Yeah, it stands for this O. And then we have division, we have multiplication, we have addition, and we also have subtraction there. So meaning addition and subtraction have to come last. When you have division and multiplication, start with them first and then end with addition and subtraction. That is basically what BODMAS is all about. So let us now try to look at the computations of binary operations. And then this is an example here. We have the example saying, consider the binary operation star defined by x star y, which is equal to x squared plus y squared minus 2, where x and y are real numbers. And then what you need to understand is that every time you are dealing with these operations, they are going to specify the numbers, rather the outcome that you need to have. So in this case, they have told us to say, when you work out this operation, but because we all know to say, when you add or subtract or multiply or divide any two real numbers, the outcome always has to be a real number. Yeah, so if we get anything that is not a real number, then there is something, not something wrong, but there is just something, there is just some conclusion that you need to derive from that expression. All right, we'll talk about it just right here. Okay, so we proceed. We have the first question here. The question is saying, is star a binary operation on R? This is a question that confuses a lot of people, this one. These others are at least simple, they are straightforward, but the first one here is what normally even some tutors don't know. I'm telling you the truth. I'm telling you the truth. This question, a lot of tutors fail to answer it. They don't know what it means. They don't know how and how to find and how to know, and why you are going to say yes, it's a binary operation, or no, it's not a binary operation. So pay attention and hear and get this point that I'm going to tell you here. So what I'm going to tell you here applies for all operations. So when they ask you to say, is star a binary operation on R, they are simply trying to ask you to say, is there a way that you can make this expression that you have been given and defined simple? I repeat, when they say, is star a binary operation on R, they are simply asking you to say, is there a way that you can put two or more real numbers in this expression and discover that the answer that you get is not a real number? Rather, is there a way? Because anything apart from a real number is undefined. So in other ways, they are trying to say, is there a way that you can make this expression undefined? If there is no way that you can make this expression undefined, then star is a binary operation on R. on all real numbers. So if this error, for instance, was Z, if this error, for instance, was Z, the question now changes. It will be like this. Is there a way that you can make this expression undefined by replacing where there is X and Y with any integer? That's what this question means. Now, since we're talking about real numbers here, we're talking about real numbers. Hence, the question is there a way that you can make this expression undefined by replacing X and Y, or any value of X and Y, by any real number? And if you look at this, when we put X, where there is X, we put 0, we put any number here, any real number, you discover that no matter how many or how great or how small the numbers that you put here, you will never get an undefined answer here. Your answer is always going to be defined, and it's going to be a real number. So this is how simple these questions are. So meaning, since there is no number that you can put on either X or Y to make the whole expression undefined, therefore, or then then star is a binary operation on R. So star in this question is a binary operation on R. Now, I know some of you are asking yourselves to say, in what situations, or how do situations look like, or how can a question look, for instance, if star was not going to be a binary operation on R? Try to look at this example here. If you've been given maybe X star Y being equal to, maybe you have Y over X. So the question is there a way that you can make this expression undefined? Simple, yes. How? By replacing X with 0. So when you replace X with a real number 0, you find that this expression is going to be undefined. So if this was the question here, if this was what was here, star wouldn't have been a binary operation on R, because when you replace 0 there, when you replace 0 there, you discover that this operation will be undefined. Now, if this was the question, and for instance here where there's R, it's not R, there is natural numbers. We know to say natural numbers are counting numbers starting with 1, excluding 0. Okay, so if here there was n, and then this was the question, here star would have still been a binary operation on R. Why do I say so? When you replace any natural number here where there's X or where there's Y, you discover that there is no possibility, there is no probability of you making this expression undefined. Because in a set of natural numbers, 0 does not exist there. So meaning there's no probability of you putting 0 there on X. I hope you have understood what I've explained. Okay, let us proceed. So according to the question that we've been given here, no to say star is a binary operation on R, because there's no way we can make this expression here undefined. Okay, so now let's move on to question 2. So when question 2 here is saying determine whether star is commutative. So for commutative, what you need to understand is that if you have X, or rather, let me just show you what I prepared here. Commutative, when we talk about commutative, we're simply talking about you just interchanging the letters. While there is X here, you put Y. While there is Y, you put X. If you interchange these letters and plug in some values, are you still going to get the same answer? Yes. Try to put where there is x, put y, where there is y, put x, and then try to plug in some values there. You still get the same answer. Okay, this is what I'm trying to talk about here. For all values of x, where x and y, where x and y are members of real numbers, we want to determine if x star y is equal to y star x. Okay, so you can see there, when you replace where there's x, you put y, where there's y, where there's y squared, there you put x squared. You still get the same answer. That's how it is. So meaning here, commutative law is, star is commutative. So according to this question, star is commutative because we're getting the same answers. You can try it on a separate paper there. Try to put any value there. Try to put 0 here and 1 there. And then in the next part, try to put 1 there on x, and then on y, 0. Yeah, you discover that you still get the same answer there. So we proceed. So question 3, this one is supposed to be 3, not 2, and then this one will be 4. Saying determine whether a star is associative. So for associative law, we know to say what you just need to move is a parenthesis. Now, somebody will ask themselves to say, here we only have x and y. Where are we going to get the third value? Because for you to exchange the parentheses, you need to have x, you need to have y, you need to have z. For you to exchange these brackets, the parentheses, meaning if the first one was like this, the second one is going to be like this. The second one is going to be like that. Yeah. So somebody will now ask themselves to say, where are we going to get the z? Because here we only have x and y. And when plugging them in, how are we going to plug them in? Simple. So here, what you do is you introduce another letter, which is z, like I did there. And then after introducing another letter, so meaning you first deal with the first two letters, because you all know to say when you're dealing with mathematics, you first start with what is in the brackets. So this is what I'm trying to say here. You introduce another letter z, and then you make sure that z is also a member of real numbers, and then try to prove this. So the way you prove this, you can either use numbers or you can use letters. But I would advise you to use letters. And then how do you use letters? I think, anyway, let me just show you numbers, because numbers is quite simpler than letters. Most people tend to make mistakes when it comes to using letters. But letters is somehow the one which is recommended in most universities. But at Mulungush University, we have professional tutors and lecturers there. So they can they also mark using numbers. Yeah. So by using numbers, I mean you take 3 smallest possible numbers that you think will not give you problems when it comes to solving them. So myself, I would like to get 1, 0, 1 like this. Make sure that you get 3 different numbers. Okay. So just remaining with 1 minute. And anyway, I'll formulate another link so that we finish up this question, because it's the last question. Yeah. So you make sure that you pick 3 good numbers, or maybe before I show you this one for numbers, let me show you letters. Okay, We just do this. Let me show you the one for letters. Yeah, so I don't know if you guys are able to see what is written here. Okay, you can see here it's written associative law, and then for all values of x, y, and z being members of real numbers, we need to determine this. Okay, we need to determine that, and then you first start with the left-hand side. So when you start with the left-hand side, meaning the parentheses will be on your left-hand side like that. So meaning while there is x star y, you replace with that given expression, the expression that we were given, which is this one here. Yes. And then you put star z outside like that. So what you do now, you work out this part. You work out this part, this side alone. So meaning this one will be your first, will be your first character, rather will be your first digit, and then z will be your second digit. Yeah, so I was saying you first start by replacing where there is x star y, you replace with that. You replace with what your x star y. The x star y which we were given was this in the question. This was x star y. So meaning while there is x star y, I'll replace with that. And then this star z outside is the one which is this side. So now, having written this, this will be my x, this one will be my, this one here will be my x, and then my y will now be equal to z. Hope you are getting me. And then while there is x in this expression, while there is x in this expression in brackets, I'm going to replace with this whole thing. And then where there is y, I'm going to put z. This is what has happened here. Here where there is x, I've replaced with this whole thing. And then where there is y, I'm replacing with z. While there is x here, I've replaced with this whole thing. This squared you are seeing on top here is simply this one there. And then this z, I mean, while there is y, I've replaced with that z. So this is the place that z has taken. This is squared on y is the one which is this here on top. And then this minus 2 is the one which is this side. I hope you have gotten. Okay. And then, okay. Sorry. Okay. And then you simply now do what? Work out the expression. You work it out, you solve them. So after solving this, so after solving this, you solve it, you have this as your answer when you simplify it. So now I was saying using letters sometimes it's a little bit cumbersome because you may even make mistakes as you are solving them. But when you're using numbers, it's very easy. I'm going to show you the one for numbers. Yeah. So this is what I'm trying to say. You solve your left-hand side, you get this answer. So in the next part, what you do is you leave the x star outside and then you move the parentheses to the next two letters, meaning your parentheses will be on y and z. You're going to have this. So now you work out your right-hand side. So you first leave your x star like that. You first leave your x star like that, and then while there is y star z, you replace with y squared plus z squared minus 2. In other words, while there is y, I've replaced with, while there is x, I've replaced with y. While there is y, I've replaced with z. And then x remains outside like that. So in this expression, this one, y squared plus z squared minus 2, while there is x, I'll replace with that. While there is x, I'm replacing with x. While there is y, sorry, I'm replacing with x. Then while there is this, I'm replacing with that again. And then I'll square it and then minus 2. And then from that, when you simplify this further, you get this as your solution. Then after getting this as your solution, you compare now this one and this one there. You compare these two. Why is it writing these things, huh? Okay. All right, you pardon me for this. So you are going to compare the two. So you are going to compare the two, and then if this one is equal to this one, then star is associative. Now, in this case, when you look at these two expressions, you discover that they are different. Hence, star is not associative. Let's go back to our slide. I show you now the one for using numbers. So when you're using numbers now, I'll start with commutative when you're using numbers. So when you're using numbers, you say let, when you're using numbers, you say let x star y, say let x star y be equal to 0 star. You just pick two smallest numbers, two smallest possible numbers that will not give you hell when solving. So myself, I like getting -1, 0, and 1. So let x star y be equal to 0 star 1. So while there is x in this expression, in this given expression, I'm going to replace with 0. While there is 1, I'm going to put 1. So when I put 0 while there is x there, I'm going to have something like this: 0 squared plus 1 squared minus 2. And then when I solve this out, I'm going to have my answer to be 1 minus 2, I'm getting -1. So I'll do this. So this is my left hand side. Now let me deal with my right hand side. So in this other case, I'm going to start with y, and then I'll say y star x. So this one simply means that even the expression here will change. While there is x, I'm going to put y. While there is 1, I'm going to put x. Hence, so y star x will be 1 star 0. So meaning where there is x, I'm putting 1. I'm going to have 1 squared minus, this is plus 0 squared minus 2. When you subtract 1 minus 2 there, you get your answer to be -1. So this is if you get the same answers, it simply tells you to say star is commutative. But if you get different answers, then you conclude to say star is not commutative. All right. So let us now see how you can apply this same principle of using numbers on associative law. So on associative law, again, you get two smallest numbers. Instead of now using x, y, z to prove, you say let x, y, and z, you put your stars there. let x, y, z be equal to -1, 0, 1. Oh, these are stars, so not commas. All right. So this is what you get. And then after doing this, you now have to start working them out. So as we said, you first start with these two numbers. So I'm going to start with -1 star 0 star 1. So I'll first put these in brackets, and then so this is what I'm going to have. So while there's while there's x, I'm going to put -1 there. So I'll have -1 squared. Of course, this is a negative number, it has to be in brackets. Then plus, while there's y, I'm going to put 0 like that, and then -2. When I do this, remember there's another number outside here which is star 1. So I will not forget this star 1. I'll put it like that 1. So I'll work out what is in the brackets there. So this is 1 minus 2, and I'm getting -1. And then I'll say star 1 like that. So here, yeah, so here what you do again, you have, okay, so here what you do again, you replace, while there is x, you put -1, while there is y, you put 1. So I'm going to have -1 squared, then we're going to have plus 1 squared, this is supposed to be in brackets, then -2 outside. So when you solve this, you get 1 plus 1, 2 minus 2, you get your 0 there. You go to the right hand side while you shift the brackets now. So you have -1 star 0 star 1. You shift the brackets. You start with what is in the brackets first. So you have -1 star. Then what is in the brackets there? While there's x, I'm going to put 0. Then while there's x, I'm going to put 0. While there's y, I'm going to put 1. So this is going to give you something like this. This is going to give you something like this. And then -1, -2. Okay. -1. And then you get here to give you star -1 again. So this will this one is a little bit tricky. So because it's going to show us that it's associative. Anyway, let's finish this. Let's finish and see what it's going to give us. So this one, when you replace it back to that, you get -1 squared, then plus -1 squared, then -2. This one is dangerous. This question is dangerous. So you are still getting a 0 again there. Then this proves to you that it's associative, but in the actual sense it's not. So such questions are the ones that we fear the most when it comes to using numbers. Yeah, so in other words, what I've just said is that you resort to the one, or you should get used to the one where you need to use letters. So get used to the one which uses letters, not numbers. because numbers sometimes it may prove that it's associative or it's commutative when it's not. So just learn how to use letters, and I guess you have understood what I explained in letters. Okay, the way I've done it on numbers is the way you do it on letters. It's just that when you're dealing with letters, you'll not be having your final answer as one number. You'll be having an expression as the final answer. And then you compare the two expressions. If they are the same, then it's associative. If they are not, then it's not. Anyway, so my advice for you is that use letters, don't use numbers. Yeah, and it's good that we have found a question which is giving us a wrong answer when you use numbers. Yeah, it's good, and it's actually good, because I've also learned one thing to say: using numbers is not something that you can trust in. Yeah, so use letters anyway. Use letters. So the way I've done the last question here, the way I was doing it is the way you do the last one here. So you're going to have your 3 star 2 star 5. So meaning you first start with 3 star 2 in brackets like that, and then star 5. So here what you start with is first what is in the brackets there. So you write your 3 squared like that, then you say plus 2 squared, then you say minus 2. So you put them in brackets. Make sure that you put your star 5 outside there. So here what you do is you simplify what is in the brackets. This is 9. 9 plus 4, you get 13, minus 2, you get 11. So this is 11 star 5. So 11 star 5 there means that you replace where there's x, you put 11, and then where there's y, you put 5. Squared minus 2. So 11 times 11, 11 times 11 there, you can calculate it, and then 5 times 5, you can also calculate it, and then you subtract 2 from it, and then you find your final answer there. Yeah, you can find your final answer there, or maybe we just finish it up. Let's just finish it up. 11 times 11 there, 11 times 11 is equal to 121. So this one will give you 121. Then 5 times 5 is equal to 25. Then when you subtract 2 there, so 121 plus 25, you get 146. So 146 minus 2, you get 144. I hope I'm correct. Yeah. So this is the solution for the last part there. So basically, this is how you deal with the computations or the mathematics about binary operations. Yeah, there is no other way. This is the only way. And then let me just make a clarification on the number 3 here. Or let me just repeat myself in case there was somebody who didn't get me. On this one here, use letters, don't use numbers. The third question here, this one. Use letters when proving for associative or commutative. Use letters, not numbers. All right. I don't know if you guys have questions. If you have questions, you can ask in these remaining minutes, and I'll respond to you just here. So I'll be waiting for your questions. You can ask You can either type it as a text, or you activate your mouthpiece there on your phone, or unmute yourself and ask it, and that's the question. Okay. Yeah, it seems like you guys have understood. But silence may also mean you have understood everything that I've explained. All right, thank you very much for attending today's lesson. So don't miss tomorrow's lesson, because we're going to start indices tomorrow. Since we're done with sets and everything, this was our last part on sets, or sets of numbers. So don't miss tomorrow's lesson. We're starting a new lesson. The most important thing every time you are learning something is the foundation, the basics. Once you know the basics about anything, it will not be difficult for you to build it up from there. Yeah. What normally helps me to solve mathematics in university or wherever I am, or any kind of mathematics when I'm given, is the basic maths that I learned from high school. Just those simple, small stuffs are the ones that I always use to solve big questions, to solve very difficult questions. Yeah. And it's not possible that a person can get a 0, or it's not possible that a person can get less than 50% when you know the basics. Just those basics are, they give a lot of marks in the exam. Yeah. All right, thank you very much. See you in the next lesson tomorrow. We're going to meet on this same platform, Zoom, and then I'll see if I have time tonight. I'll prepare an exercise on binary operations. I need also to know whether you have understood or not. All right, good night. Shalom, shalom.